Uh, Hey guys, welcome back. I hope you're already having a very exciting and energetic day at our ATA GTR 2021. It gives me immense pleasure to introduce our host for the next track one or next or the first track one topic, which is AI in testing. Why idea whose time has come, which is a very interesting topic, which I've been actually waiting for all day to listen to. Let me introduce the speakers for you. So we have Adish and Meena today. Adish has about 25 years of experience in IT. He is the head of large deals at L&T Infotech. He leads the product management of key solutions suite within the new ways of working group at LTI Pune. Um, he is keenly involved in productivity engineering by leveraging AI, ML, which is actually his key area of focus. We also have Meena. Meena is a product architect at LTI Pune. She specializes in design and development of AI ML based products. She has IPs in data analysis, IoT, digital customer experiences, etc. in these areas. Um, she has a perfect background in AI and testing as well. I can't wait to actually listen to both of them speak about AI and testing. Over to you, Adish.
Thank you so much. I think I need to kind of update my LinkedIn profile because I'm now in the new ways of working group full time. So good, thank you. And I think it's very stimulating session in the morning. And I think thanks, Michael. Some of the insights that you gave in your keynote were just riveting. Having said that, there's a challenge I have. So this is a post-lunch session. Our presentation is going to be long, boring, soporific, tedious, tiresome. That's where my GRE vocabulary ends. But the thing is that you guys need to be interpreted in a more informative and inspiring way, and that's called teamwork. Okay, but and let's get on to the topic. Yeah, why is AI-driven testing, a very exciting space to be in? And I've seen, most of the other there are lots of other topics which are going on in parallel, and will be going on throughout the days. And I'm sure everyone is equally, tied up to their ideas, and we are tied up to AI-driven testing. And as Victor Hugo once said, that an idea whose time has come, no armies can stop it. And I think there is merit to this, and this is what we're going to put in front of you. And what are the big drivers? One is, of course, the pandemic. The way the world is negotiated pandemic, at least the business world. In LTI, we call it the great restructure. So we are talking all about how do you how it's about enhanced empathy, improved productivity, building resilience, and increase agility. But having said all that, if you look at practically, the way we moved last, I think what, March 2020, and we moved suddenly working from home. All these tools like Teams and all became our best friends. We were constantly on conferences, never leaving a seat. Many of us having various kinds of back problems because of our we're not the ergonomic way of sitting and all those aspects. But there is the workplace has become more democratized. We are working all hours, we're working across the globe, and in that model. So that's one aspect of it. But the two other big forces is SDLC itself, your software development lifecycle. If you look at software development, across the software development lifecycle, a lot of assets are generated: test cases, defects, code files, requirements, and there is a whole opportunity to mine this information that's there. And the tools to mine those information is natural language processing. There's a paradigm shift that has taken place in natural language processing. I'll be coming to a bit in a minute, but that's where I was disagreeing with Margaret in the morning, the first the keynote speaker, and she mentioned that she doesn't do detailed test cases and such, and it's more exploratory and make few notes. And but that is okay when you're yourself an expert. But the kind of information when you create and test cases and all, and the ability to mine it is phenomenal today with the natural language processing. And that's what we'll come to in a bit. So where is it our pitch coming for in AI, in software engineering, or in software testing? Uh, you can apply AI for test automation. You can apply for AI for creating test cases, but we are looking at a slightly different space. We are looking at insights. Yeah. So if you look at on the, let me just kind of get my pointer going. Yeah. So if you look at the and I hope my voice is I'm audible, right? Just because I can't see anything, and if you're okay, I'm nice and audible. I can see that. All right. Okay. So yeah. So let me just get that. Just 1 second. Let me just get my pointer. So if you look at, sorry, this is a rather busy slide post lunch. Excuse me. I think this will be the last slide, and maybe one more slide after this, which will be busy with words. But if you look at it, what we are looking at is at the space of optimization. We are looking at two places. One is analytics using machine learning, and looking at opportunities of insights through correlation. Let me give you an example. If I look at all the defects that are there in a typical defect lifecycle management, can I look at all the defects, thousands of defects? Can I look at the summary? Can I look at the description? Can I look at the root cause analysis and mine insights out of it? Yeah. Can I create defect hotspots? Can I create a defect hotspots which tell where in the software the issues are, where the pain points are? Is that possible? Can I look at all the defects release after release? In any, and with number of sprints, the amount of data that is coming out. Can I look at the defects release after release and predict the next defects? Predict the defects that are likely to happen. Yeah, from a test manager perspective, that's immensely useful, right? Or and you can look at requirements. You can look at requirements. You can look at only at test cases and see if there are any any opportunities to regression design, which are the most used test cases, so on and so forth. So this is, I'm looking in a particular stove, one particular stovepipe, one particular tower of defects, of incidents, of requirements. The other opportunity which I can look at is end-to-end correlation. Yeah. Can I build an end-to-end correlation across the requirements, the test cases, the defects, the incidents, the code files? Yeah. If I can build that traceability end-to-end, and that's always been the holy grail for us, right? We've got all these SEI, and all these processes, enable that traceability. But in real world, the speed at which we work, and various varied tools we work on, it's and partly in manual Excel sheets, partly in tools. It's becoming very difficult to do that kind of traceability, and that is where today the tools that AI is providing, and when I say AI, please read it as natural language processing predominantly, is allowing you to build that correlation. Okay. Now, let's say if I have that correlation done between requirements and test cases, is there an opportunity? Can I look at the an automation opportunity? Which are the test cases which are most which touch the highest requirement test complexity? And then can I look at opportunities to build automation opportunity? I think there was a term used by Michael as quixotic reliability. I'm also talking about quixotic unreliability. Many times we hit a defect which just doesn't come, for which we need production environment, or which is just too elusive. Now, defect root cause analysis. If I have a defect, and if I can then take the entire correlation end to end, so I have a defect, I look at what test cases is associated with it. I take it back to what requirements is it coming to. And then I look at what code files is it associated with. And then I use external tools for code files. So there are lots of call graph or architectural, underpinning tools like Cast. Can I then feed that code to those existing tools and look at at the entire defect and try to solve that defect in a very different manner? Yeah, these are the possibilities that are now becoming real with AI and machine learning and NLP. Because it's 2:15, I presume we'll be closing at 2:45, right? So if it's otherwise, yeah, and just give me a 5-minute ping, because we might just go overboard.
No, that's correct, Adish. We would be moving ahead by 5 minutes.
Yeah, cool. All right. So let me, where did I miss that lovely slide of mine? Did I miss it? Oh, I didn't. Oh, I just missed a lovely slide just to keep the energy going. But anyway, that's where it is. All right, fine. Come down. No, it's not there. All right. So it was one little funny little slide to just get things moving. So let me tell you what are the tools. Because I got a little inspired by Michael, and I'd taken my a photograph of my workplace of I'm fiddling a lot with electronics nowadays. So what are the new tools and what are the new techniques and what is the new experimentation? So in the last 5 years, a lot has happened in natural language processing. Means we've had something like n-grams, bag of words, since 1948. And you have the recurrent neural networks, long short memory, long short term memory. All that is there. Topic modeling, lots of things have been happening for the for last maybe 5 or 6 decades. But if you really look at it, and if you look at the turning points in 2009, GPUs were you used for the first time, and this is Andrew Ng using GPUs for the first time for image processing. Yeah, so those are where things started really popping up in AI in a very meaningful terms. And I don't know if you're following the share price of Nvidia versus Intel. Nvidia is today almost $800 billion in valuation. So GPUs, after 10 years, have really started realizing their full value. And in the meantime, you've also seen IBM beating Jeopardy. Interestingly, I didn't mention it over here. So there are these two big things which have happened. One is the whole word embeddings. Yeah. So what was happening in the first 10 to 15 years, or maybe last 10 to 5 to 10, 5 to 5 odd decades, was all to do with basically text summarization, classification, spam identification, or it's classification like spam, identifying spams, or sentiment analysis. These were the typical use cases, but there was no semantic relation. Yeah, that what is the meaning of a word? What it was just count of word, and there it was. But with word to vec, which was done by Google and Glove in 2013-14, the word embedding started coming up. Yeah, and you could now find analogies between words. You could find semantic relationship between words. Yeah, and then you could go for next word prediction. What do you do in Google today? Or the next word prediction, what it gives you, or recommendation engines. These are the things which started coming up. But again, with these word representations and shallow word embeddings and shallow representations, it was still a challenge. We had long sentences, you couldn't get contextual meaning of it. Yeah, but now it's only now in the last 3 years, and I think there was a seminal paper by AI, attention is all that matters, by Mr. Vaswani, Ashish Vaswani, and a couple of other researchers from Google and University of, I think, anyway, one of the Canadian universities. They came up with this paper, and we're now having a complete transformation in how sequence to sequence and language models are being progressed. And just to give you a data point, there is, if some of you are interested, you can go to Glue research. It's a Glue dashboard, like the leadership board we have over here. They have a leadership board, and there are some 8 or 9 language tasks that are given, comparing sentences. Is the sentence a part of other sentence? Is the sentence grammatically correct? And so on and so forth. There are 8 such tests. And today, in March 2019, these models, transform models, have beaten human capability. Yeah. So just to tell you, within 2017, to 2019, these models have been beaten. And if you've heard about GPT-3, BERT, and host of other models that are coming in, you should be just watching this space at how language models, these models, transform models, and the encoder decoder models are coming, and how they're transforming the way the NLP techniques are looking at language. Now you might be getting a little bored, and saying, "Hey, hello, what do you mean? Show me what it means in the real world." So I'll now request Meena to take through what does it mean that once you have these language models and once you can build these correlations, what does it mean for a software tester? Meena, over to you.
Yeah. Thanks, Adish. So yes, and Adish has explained us the two different worlds, right? What is that we are expecting from testing point of view? what all use cases we can, solve those use cases with the help of machine learning, AI, all those techniques. And then he has explained us whole lot of that, what all revolution has happened in this world. But how do I correlate this two different things, right? And that is where our point of view is, a lot of data. I mean, it is all about data, and a lot of data is being generated. Any area, right? Be it a business world, anything. But what we are living in is the SDLC. The way Adish has mentioned, after this pandemic, we are now living in the tools, be it meeting tools like this, MS Teams, Zoom, WebEx, right? And even our work is in the SDLC tool data, and whole lot of data is being generated, but we are not utilizing that data. So even every software project, it generates enormous data in terms of requirement documents, user stories, test cases, code files, user manuals, logs, and a hell lot of that. Can I leverage this data? Can I leverage this data and solve some of the use cases which Adish has talked about? Okay. So how can I do this? How can I build? I mean, how can I relate this all different entities, and how these entities can help me to solve those use cases? And that's where I call it as a knowledge correlation. The graph which we are right now looking on the screen is the knowledge correlation. If I can build the relation between these different entities, right? If I talk about user stories and the test cases, maybe in some of the tools I can get that correlation. But how about the test cases and code files? Those are totally two different worlds, right? I mean, when developer write a code, it is in those languages, Java, .NET, Python, and all, with all those syntax and all that. It is nowhere related with the, I mean, it's very hard to relate with the user stories, which is written in very English or layman language, right? But how if I can leverage this techniques, say NLP techniques, and build that correlation? And that is what we are talking about. So there are multiple approaches. It is not just with the NLP approach. We can also go with the instrumentation, the way we do for mobile testing, right? We can always instrument some code and get the correlation built. Then there are manual correlation, the way we get in the any test management tool like Jira, ALM, and those sort of a test management tool where your test cases and defects are correlated, your user stories and test cases are related, and you can build that correlation. Now, once this correlation is built, how it is going to solve my use cases? And for that, I would like to take one example. I mean, all of us understand the banking industry, right? So here is, I'm going to explain, I mean, I'll leverage this example end-to-end use cases, end-to-end use case. So let's say there are multiple applications coming from different, line of business within the banking domain. So some could be with the internet banking, core banking, there could be a credit cards and all those different areas, right? And we have lot many application within those areas. So I call it as a value stream, and then within value stream there are multiple application. Again, for each of the application, I'll have a multiple use cases, releases, whole lot of code files, test cases, defects. How if I could build a correlation and use that or leverage that for my further releases? Okay, so the use case is there is a change. There is a change going to happen for a premium payments. So if you remember a few years ago, whenever we do a payments, it is usually it doesn't reflect on the same day, right? I mean, it takes some amount of time, and that is because there are some batch processes running at the end of the day or end of the week. which will take some time to reflect that what are the payments we have done against, it could be your policies or it could be anything, right? So let's say if I want to change from batch payment to real time, what all systems will be impacted? Okay. So it is not just the change where the code change is going to happen, but then there could be some intermediate applications as well, uh, which are going to take a part while that use case is going to execute. So for that end-to-end use cases, there could be some application from internet banking, multi-channel engine, notification engine, core banking, credit card, and all those. And again, with all these application, there would be a lot of different technologies as well. I mean, some application could be a web-based application, whereas some could be a mainframe application, .NET, Java. Nowadays, the cloud-based, products which we normally leverage. So within all this, can I find out, where is my test suite? What exactly the bunch of test cases if I have to pick up, can I identify that? And that is where this correlation, which we have shown just one slide above, that is going to help me. So when I'm doing a change, so let's say a developer is going to do a change in a application, which is the internet banking application, there are certain code files going to undergo a change, right? And if I have the knowledge map or knowledge correlation, I can find out that, okay, this is the branch or this is the end-to-end branch where, my code files are going to change. And with those code files, there are certain, set of test cases which are going to be impacted, right? With those test cases, there are some defects which were identified earlier. So do I need to look at those defects when I do my regression testing? So this is what, the possibility of building a correlation. Again, all this SDLC data is, I would say, heavily textual data. So it is very difficult to relate that data with each other. So if I take an example of test cases or a description, it is heavily described in a textual manner, right? And it is very hard for someone to directly put some query and build that correlation. And that's where this NLP techniques can help us to build that correlation and come up with that, priority one test cases. Okay, these are my priority one test cases because these code files has undergone a change, and because of that change, these are the test cases. These are the defects which I have to look at. Along with that, I mean, I can also look for any other recommendations. So the way recommendation engine works, right? So with the priority test suite, are there any other related test cases which I need to look at? So that is also a use case which I can, look from a quality engineer perspective. The kind of defects which I can predict, the way Adish has mentioned earlier, right? The optimal regression suite. So rather than executing the entire 1,000 set of test cases, can I optimize my regression suite and just focus on those, 400 test cases which I get correlated or which I have built after that knowledge correlation map. I can focus on those test cases as a priority test cases, and then maybe for a priority two, I can keep some other test cases. So that is another, I mean, that is the question as a quality engineer I can have. What if, what is the guarantee that I am covering, I am having optimal test coverage? So, I mean, my question is why not? Because I'm looking at the code base, right? I exactly know what all code files has undergone a change, though I don't understand uh, I don't understand what developer has written as a logic inside that code files, but I know that these are the files which has undergone a change, and with that, with the correlation, I can find out the test cases. So that is where I'll have a level of assurance that I'm covering the best with respect to the changes what is happening. And yeah, and even the test data, do I need to create new set of test data because I already have a correlation? If something new is coming up, do I need to create new set of data, right?
Okay, sorry to
So
interrupt. Couple of
yeah,
more minutes before we start taking questions.
Yeah.
yes. So yeah, so there are a lot of use cases which we can solve and which we can help different personas throughout the SDLCs who can get beneficiated out of this.
Yeah. I think
Yeah,
there are just 2 slides and that's it. So these are the last 2 slides. So let me just tell you that, the whole trick is in getting all this data. I think data is a challenge. At the same time, it's becoming an opportunity as we move more towards a hybrid workforce, using more and more tools. So, and you can see the amount of data that you can collect. And we are not just looking at text data and all. We are also looking at audio and video. So you can also do transcript. So going back to that previous use case, where you're looking at high customer values, change for batch payments. You can actually search this which all use cases is getting impacted. Is there an SME who has made audio recording, and can you look into that audio recording? Can you correlate it end to end? Yeah, right across the requirements, test cases, defects, code files, incidents, and can you derive more information, more insights? Is what is being possible once you've collated all that data, put it into a data warehouse, created that knowledge fabric, and then exposed it to various end users to create, to draw out on their plans. Last slide, and I think this is fairly self-explanatory. So we looked at value creation. How can I reduce cost? How can I improve quality? And how can I reduce my time to market through various use cases in testing? So test optimization, defect reassignment, defect prediction, faster turnaround of defects, so on and so forth. I'll leave it at that so that we can take in a few questions.
Sure, thanks. I think there was a note from Marit. Basically, I think for Adish, I hope you could you read it.
Yeah.
One interesting question from Michael Bolton on this seems like could be interesting. Can you show an actual example report?
Can you show an actual
example report?
Okay, of use of AI of these use cases.
Yeah.
We means the thing is, this is we will be touching into some of our client confidential stuff, but what we are doing right now is how can I optimize my regression testing? So that we are actually doing it by seeing what the release notes are there, what are the changes that have taken place, and we can actually show what test cases are getting impacted. Potentially what test cases are getting impacted. So that's itself one use case where we can significantly reduce. We are also looking at, if a defect is allocated to, if a defect has to be allocated to a developer and resolve faster, can I look at all my previously resolved defects? Can I compare it with that and find similar looking defects and solve those defects faster? That could be a second use case. Third is, as I mentioned, these defect hotspots, and these are delivering value. Means we are doing it for our customers, these various use cases. Look at defect hotspots itself. Yeah. Can I look at all the summary of the defects and description of the defects, the defect logs, thousands of what is there, and can I club them into logical hotspots? So that's another use case. And then it is correlated with your modules. And if the modules are changing, if the code is changing, I can, as a test manager, I can then take proactive actions for solving these defects. So we have got clients who've got more than 30 or projects, and when I talk to the test manager, they've said there's significant cost reduction, more than 10% reduction just through these defect hotspots. Change impact, before if the change is coming, if the release note is coming, and there are changes which are coming, and as a test manager, I would want to see what user stories, what test cases, what prior defects are there, which I can look at and plan for my regression testing, plan for my forward-looking testing, right upfront in the life cycle. So the opportunities are huge. And Michael, maybe separately, I can showcase specific data to you. I don't have it right now, but yeah, we've got time a dozen examples to show.
Sure, I think something similar on the lines from Jeevan Linkappa as well. So we have readily available tools for test lifecycle management like Octane, Jira, HPLM. how different AI approach here. But I think the question is more on how do we leverage AI to actually make these applications, make the data that we get from this application to consume the data and make some sense out of it. So that's really what I think Jeevan meant.
Yeah. So one is, okay, if you ask me, that some of these tools, they're focused on the transactional part of it. That itself is a huge tactical activity. Getting all the data defects, having all the data log, root cause analysis logged, all that aspect is there. So collating this data is a big activity. So you have to connect to these tools like Jira, ADO, and all. We have connectors which we connect to them. We get all the data into a data warehouse, and that's where you kind of start processing on top of it. So then you have the machine learning algorithms on top of it. They do the correlation, they do the data clustering. We build the knowledge ontology on top of it. We build the knowledge graphs over it, the knowledge fabric we call it, and that's then something which can be then used by end users for solving their use cases. Yeah, you're on 245.
Yeah, thanks a lot. There's one more question from Michael, basically a follow-up question from Michael. I hope you can answer it on chat. And there's one more question from Ashish as well. Could you please take that up on chat? And maybe I'll just take control for a quick word of thanks.
And yeah, thank you so much. I appreciate everyone on the call, more than 200 people. So I really appreciate you guys being there.
Yes, of course. It's an awesome session. It's an eye opener for most of us, and especially I was actually struggling from a correlation point of view. I do have some questions on the tools and techniques that you might have used, but maybe I'll take that up in chat. But thanks a lot, Adish and Meena, for taking the time out and giving us a very informative session this afternoon. Thanks again.
And vice versa. Thank you so much.
Thank you so much.